to verify this identity, it looks pretty dang complicated. Both sides look pretty complicated, but I think I think most would agree that the left side of this equation looks quite a bit more complicated than the right side. And so I am going to work with that. I'm going to start with this square root of 1 plus the sine of x over 1 minus the sine of x. All right, now at this point, I'm looking for something to do. It's already written in terms of sine and cosine, well, just sine. I don't really see any identities. I don't really see operations that I can do that would make this actually work out nicely. So it feels like we're kind of stuck. However, one nice thing is we do know that there are identities out there that can be useful to us. One of the identities is the Pythagorean identity, that sine squared of x plus cosine squared of x equals 1. There's a lot of things that comes from this identity. A lot of things that come from this. And this can be written in a couple different forms. I'm just going to go ahead and subtract the sine squared from both sides. So I get cosine squared of x equals 1 minus sine squared of x. And the reason I'm doing that is because I do see a 1 minus sine of x. Okay, it's not 1 minus sine squared, but it is 1 minus sine of x. So it kind of looks like this expression. And there's actually a way that we can get that expression, okay? And that's where we have to remember the factored form of 1 minus sine squared of x. This is a difference of squares. So this is 1 minus sine of x times 1 plus sine of x. And by remembering that factored form of this, we can use that here. We can say, oh, I'm going to take this and I'm going to multiply by something that will give me this factored form. And you'll notice that actually both of those show up here. So I could either change the numerator or change the denominator. Let me point out what would happen. If I were to multiply by a 1 minus sine of x, okay, if I were to do that, I'd have to do it on the top and the bottom. Okay. Now I'm just gonna think ahead for a second here. If I were to do this, my numerator becomes cosine squared of x. Okay, and then I do the square root, and I'd end up with a cosine in the numerator. And this is where it's important to keep the goal in mind. The goal is to end up with a cosine in the denominator, not the numerator. So that tells me that maybe multiplying by 1 minus sine of x is not quite right, because then my numerator becomes a cosine, which is not what I want. So I'm actually going to multiply by 1 plus sine, and then notice now that my denominator, I'm going to have my 1 minus sine times 1 plus sine, which is cosine squared. Square root of that will give me the cosine in the denominator. So that tells me that that's probably the way that I want to go with this. So let's go ahead and do that now. So I have still underneath the square root. Okay. In the numerator, I've got 1 plus sine of x times 1 plus sine of x. That's 1 plus sine of x squared. Okay. Over, now my denominator, 1 minus sine of x times 1 plus sine of x is 1 minus sine squared of x. Okay. Now that is an identity. So I'm going to go ahead and use this previously established identity, the Pythagorean identity, to say that that is equal to cosine squared of x. All right, now I have an operation that I can actually do. I have a square root, and it's happening to two different things that are squared. So I know how to deal with that. Now we have to be careful, because the square root, this is what we call the principal square root. It's a positive in front of this. And so when I take a square root of something, I just need to make sure that I'm going to get a positive number. Now 1 plus sine of x, if I square it and then take the square root, I get 1 plus sine of x. And this is always positive, because sine of x is stuck between -1 and 1. So I can't get a negative here. It's either 0 or it's positive. And so when I do my square root, I get my positive, I'm good there. However, the denominator, that's another story, because cosine of x might be a negative number. And when I square it, I get a positive, and take the square root, I get a positive number. So this actually is either cosine of x or negative cosine of x, okay? However, remember that up here, we're told that this is true if cosine of x is positive, okay? So I add that here and say it's this cosine of x if cosine of x is positive. And that's the identity. That is what I'm trying to verify.